Hello, hi everyone. I hope I am audible to each one of you. Thank you so much for joining in. Wonderful evening, good evening to everyone joining in. I see a couple of comments coming in. Good evening to all. Thank you so much for joining in to the introductory and problem statement explainer session for the Sugar Next Hackathon. We are here to discuss more about this hackathon today, and we're really excited to see the enthusiasm that is coming across and the amount of people who are showing us great responses coming in for this hackathon. We are truly excited to put together this session for you to understand the problem statement and your journey more in depth and with the help of our esteemed speakers and industry leaders who will be joining us shortly onto the screen. So while you guys have registered yourself, some of you must be watching this for the first time. This is truly an amazing journey that is lying right in front of you. If you've already registered, there is a lot for you to explore. And if you haven't really yet, this could be one of the reasons why you're watching here. And do check this out, watch us till the end, and you might find a good reason to join in to this hackathon as well. So thank you so much once again for joining in. So I'll just quickly walk you all through the entire process of the hackathon. What is it all about? What does it hold for you to join it? And then just a small glimpses about the timelines and the journey that it holds for you. We'll also quickly deep dive into the hackathon functions, the problem statements. We'll hear it from the industry leaders who have actually fetched it out with a lot of industry experiences, and you are open to ask any questions to them as well. Use the chat box on the YouTube itself and do post your questions if you have any. We would be more than happy to address all of your questions. If you are not a participant, if you're curious to know more about this hackathon, do post us on the chat. We will keep you posted around it. So I'll just try to share my screen real quick. Great. I hope all of it is visible to you. Great. So, like I said, it's a great initiative. It's a great initiative for you to join in. It's not just another hackathon. You might have come across various hackathons in your, if you're a veteran for hackathons. This is the premium industry platform committed to shaping the future of Indian sugar sector through technology transformations, innovations, and meaningful knowledge exchanges. So while we speak about all of these, you will experience the, knowledge, you will experience the veterans coming in onto the stage and talking about the problem statements and how you can build unique solutions around them, right? This is a hackathon where you can actually make meaningful solutions into the sugar tech industry. So the platform is designed for diverse audiences. We are open for diverse audiences, including sugar mill owners, coming from startup ecosystems to innovators of all kinds. So this is not stopping. The sky is the limit. This is not your boundary. You can participate any day if you're willing to build a solutions around sugar tech. This is your platform. Do check it out. We'll talk about how the participation will take place. I'll just give you a quick glimpse about the hackathon web page. I'll give you a glimpse about how the dashboards for submissions look like. But moreover, we'll deep dive into all of those details while we speak throughout the session itself. So we'll invite our esteemed panel very soon, and then they'll going to just walk us through the entire process of the hackathon, their vision of building this hackathon, and why the problem statements exist. What's at stake, right? It is about participation. You all know how hackathons work. There is a huge 16 lakh worth of prize pool, right? I hope that is something that you can barely see around here in other hackathons. Eight winners from eight different problem statements that are listed on the website will be declared as winners and taking home 2 lakh of a prize pool as winners from us. You also hold definite opportunities if you have unique solutions, unique innovations around any problem statements for initial seed fundings as well. So do check it out. Do read about the problem statements. while the mentors will also join us and walk us through. If you have any questions in your mind, which will help you build better solutions, better innovations, this is your platform. This is your day to ask the right questions to the right people. You can always reach out to us through our support lines, but why not hear it from the industry veterans who have been doing this for a longer period of time? So that's the timeline that looks like. So registrations are open till 25th of Feb this month itself. You can also form your teams. You can also make your idea submissions, work around it. So make sure you register yourself. You invite your team, fellow members. You form up a great team, assemble your team, bring in great solutions, great ideas around it, a problem statement, and then we'll move forward. Make a submission. We'll do the shortlisting. The shortlisted teams will be proceeding further with the prototype development phase. There will be other set of sessions happening every now and then for us to help you guys build better with the help of our mentors panel as well. And then we'll take forward with the PS explainer, etc., and take things forward from there onwards. So that's that. And with that, there is induction session, mentor-mentee connects, finale prototype development round. And not just that, there is also a final shortlist announcement wherein you will be invited to pitch right in front of a jury panel, to pitch right in front of esteemed panel and esteemed veterans from the industry, your unique solutions right in front of them to win from a cash pool prizes of 16 lakh rupees. With that, this is more just glimpses about the hackathon, and this is like in and out that you wanted to know to participate. But we would love to hear more about from the people who have actually curated this, from people who have actually given the vision of why this hackathon should exist and what is the vision behind doing this hackathon. For that, I would just like to call upon stage Mr. Deepak Malik, Director General, ISMA. Hello, sir. Very good evening.
Hello, good evening, and thank you for having me in this wonderful launch of our hackathon. Welcome to all our panel experts, participants, and the H2S execution team. The Indian Sugar and Bioenergy Manufacturers Association, famously called as ISMA, we are the premier industry body representing sugar mills and bioenergy producers in India. ISMA serves as the principal interface between the sugar industry and the government. We normally advocate enabling policies, we publish industry statistics, and promote the sustainable growth of sugar and the bioenergy sector while safeguarding the interest of producer and specifically working for the interest of sugarcane farmers countrywide. So we are happy to say that we have ISMA has taken this wonderful initiative to launch the ISMA SugarNXT Hackathon 2026, a first of its kind national innovation initiative aimed at accelerating technology driven transformation in the sugar industry and also the bioenergy sector. This particular initiative, that is Hackathon, is designed to foster new innovations, solve practical problems, aligning with the real industry needs. We have curated 8 industry defined problem statements, which is basically the central theme and objective of our hackathon. We are guided by 4 very eminent and famous industry experts who are present in this particular program. Shri Narendra Mohan Agarwal, he is advisor to ISMA. He is also the managing director of Green Tech Consultants. He was the former director of National Sugar Institute, Kanpur. We have Mr. Shri Sunil Sehgal, Sunil Singhal, Chairman and President, Chemical System Technologies, New Delhi. He is helping us out with hackathon and also a jury member for the problem statements. We have Shri Vivek Verma, Chairman and Managing Director of SCDL, and Mr. Shri JJ Bhagat, Managing Director, STM Projects Limited, New Delhi. ISMA strongly encourages participation of students, researchers, faculty members, startups, and technologists in this particular hackathon so as to develop practical and scalable solutions for the key industrial challenges in the problem statement, including the process and equipment modernization, quality enhancement, AI driven automation, energy efficiency, bioenergy development, waste utilization, and sustainable manufacturing. With this, I thank you all for participating in this wonderful initiative, and we wish you all the best. I would now hand over this to Hack to Skill team to take this session forward. Thank you very much.
Thank you so much, sir, for your your vision behind doing this hackathon. Thank you so much for your precious time as well, walking us through this hackathon itself. And thank you for hosting this as partners. And we are truly excited to see a lot of solutions coming forward, and you especially looking into it. And thank you for your time as well. So, with that, we would love to have our esteemed panel of speakers and to introduce and to walk everybody through. Before I hit onto that, I'll just share. Okay, try to share my screen real quick. Great. Okay. So, we have our definite eight problem statement. Just like how Mr. Balani has mentioned, right, that we have eight problem statements across the entire hackathon, and this is how we're going to move forward with. All of you have the opportunity to select one of the problem statement and build a solution around it. So these are the four problem statement that you see, which is developing MOC for high impact cane preparations, microfiltrations for high yield juice clarifications, advanced molecular separations for crystal pure juice, AI driven cane to bag zero touch manufacturing. There's converting flue gas waste into process energy, precision AI for cane quality assessment, smarter cooling for maximum sugar recovery, transforming sugar byproducts into high value future fuels. So these are our eight definite problem statements right there. And to help us explain more all the problem statements in details, we have our esteemed panel of speakers who are going to join us real quick onto the screen, and then we can actually take things forward from there. So for that, we have Professor Narendra Mohan Agrawal ji, Mr. Sunil Singhal ji, Mr. Vivek Verma ji, and Mr. JJ Bhagat ji. We request all of them to be here with us today. Hello, everyone. A very good evening. Thank you so much for joining in. Uh, I hope I'm audible to all of you and you can hear me. Thank you so much for sparing your valuable time to help us explain the problem statements. So what we're going to do is we're going to walk everybody through the problem statements one after the other, and we can take things forward like that. And to begin with, may request Professor Narendra Mohan Agarwal ji, advisor ISMA and managing director, Green Tech Consultant, to actually take us forward with the problem statements and help us explain problem statement number one and two. So that's the first problem statement out there. If you can take it forward, Professor Agarwal.
Thank you, Shaka. You can hear me.
I can hear you. Yeah.
Am I audible to all of you?
Yes.
Yeah, thank you so much. First of all, my compliments to ISMA for taking this wonderful initiative. And hopefully, we are going to get some very innovative ideas during this hackathon, and which are going to help us, transforming this Indian sugar industry or sugar industry across the globe, making it more sustainable, viable, and competitive. Now, coming to the problem statement for all of you, I'm going to speak for two problems. Uh, just Shakti screen the first problem statement, which is with respect to developing some material which is different to the material which we are using for sugarcane preparation. So just to give you an idea about what what we mean by this particular problem, sugarcane which we grow in the fields is taken to the sugar factory, but it is not crushed as such. The state in which we harvest it, it is to be cut into small pieces. It is fiberized, very small pieces, just to extract more and more juice which is available in the cells. So this task of cutting sugarcane into very fine chips, fibrous chips, is carried out with the help of cutters and a special mechanism which is known as shredder or the fiberizer. Uh, in either case, for in the case of the cane knives or in the case of the fiberizer, we use some special steels. But in this case, where in knives we are using the Tistrol steel having hardness with respect to 45 to 48 HRC, or generally people use in fiberizers the hammers which are having the domite tips, 650 to 700 bhn. Despite using the best quality of the material known to us, the problem is every crush, every certain amount of the crush, you have to replace the knives, or you have to the reverse the tips of the fiberizer hammers, which takes time. So you have to stop the crushing after some time, maybe after crushing 40 lakh quintals of the sugar cane or 30 lakh quintals of the sugar cane, depending upon the status or depending upon the fiber content in the sugar cane or many other local conditions. But to cut sugarcane into small chips or to fiberize it, whether we are using the cutters or we are using the fiberizers, you are supposed to take care of your knives and the tips in the hammers after certain crush. So once you are doing the the changeover, you are replacing the knives or you are doing something with the tips, you are stopping the crushing, and you are wasting or you are having some downtimes. So what we are looking for some improvised material of construction for high impact sugarcane preparation. So can we have some material which is having the properties not requiring any replacement during the season, but sugarcane or sugar industry is very seasonal. We are having a season of 150 to 160 days. So if we can get some material which is not requiring, which is a very having very improved metallurgy, and the design innovation can also be considered. So can we have some material which can be used for fabrication of the knives, or which can be used as tip for the fiberizer, not requiring frequent changes, so we can avoid the downtimes, we can lessen the burden on the sugar factories. But few things which are to be kept in mind, that it should be cost effective, and then it can sustain for the whole crushing season of the 5 to 6 months. And the cane preparation ultimately which we are going to get should have the equal or better index of the preparation. So this is the first problem statement which is coming from my side, which is with respect to having some improvised metallurgy of the for the cutters and for the hammers of the fiberizers or the shredders. Now can we have the problem statement 2, or Shakti, or yeah. Now, second thing is which is related with the sugarcane juice, because we have to take out the impurities from the sugarcane juice in pursuit of making good quality of the sugar. If those impurities remain present in the juice, we cannot have very good quality of the sugar, or it is very difficult to process the sugarcane juice to get the sugar, the yield and the quality of the sugar as well. So we do clarification of the sugarcane juice once it is extracted. So first stage is the extraction, which I've already discussed. We have to prepare the cane, we have to mill it, and we have to get the juice. Now, once we receive the juice, it contains many suspended impurities, and we do filter it. There are some conventional methods to filter the juice which is extracted at the juice extraction stage. But still, the juice which we get after filtration in the conventional filters, maybe the rotary juice screens or the stationary veg wire screens, they contain around suspended material to the extent of around 2 grams per liter, or even more than that. People have gone for some improvisation in the filtration technique also. But what we are looking for still better quality of the filtration system, because if we can remove those suspended impurities, we are going to put lesser load on the clarification stage, and we are sure that we are going to get still better quality of the sugar. So my, or the requirement or the aspiration of the ISMA is to see that having some idea where we can have superior filtration labels, having minimum suspended solids in the sugarcane juice. Once we filter the sugarcane juice through improvised filtration techniques, the solution should be doable, implementable, and there should be clear-cut idea how we are going to implement the same in the system. So this is regarding problem statement 2. Over to you, Shakti.
Thank you so much, sir, for briefing us on these two particular problem statements. It was wonderful speaking with you. So, may I request all the participants, if you have any questions related to problem statement number 1 and 2, please do drop us in the chat box. We can pick up the questions once we have explained all of these questions, all of the problem statements here. And then we can actually ask the questions to our esteemed speakers, and they can help us address those. So if you have any questions related to problem statement 1 and 2, please do drop them into the chat box. So with that, our next esteemed panel speaker is Mr. Sunil Singhal, Chairman and President. Hello, sir. Very good evening. I hope you can hear me out. So, yeah, so Mr. Sunil Singhal will help us explain problem statement number 3 and 8. So, for those who have selected out problem statement number 3 and 8, they can absolutely just hear out what Mr. Singhal has to say. So, I'll just flash this onto the screen right away. If you can hear us, Mr. Singhal, you can just go ahead with problem statement number 3 here.
Okay, so basically the production of sugar for a layman consists of two things. One is to remove the impurities, and two is to remove the water which is coming along in the cane juice. Once you have done that, then you can easily crystallize the sugar and get it out as a finished product. So there have been various ways and processes developed over the years and that are in practice today, wherein the impurities are removed either through precipitation or through filtration or through sulfitation or through carbonation, etc. There are various methods, and some of these are common practices today. So what we are looking for, some innovative ideas on removing some of these impurities. These are dissolved impurities. So we are not talking about suspended matter, which has been covered in the previous problem statement. We are looking for dissolved impurities. So there are various inorganic material that are coming from the juice in the sugarcane. These are the calcium, magnesium, sulfate, phosphates, etc. that are present. And so we're looking for techniques, methods, prototypes that can remove these material. And also, as I said, the color. So the coloring matter, there are various kinds of coloring matter present in the sugarcane juice. And as you can see, the sugar is without any color. So obviously, this color has to be taken out somewhere along the way. So we are looking for new techniques for either for decolorization, wherein the color is removed or through some kind of a separation technique whereby the colors can be removed out of the system. Of course, the energy requirements in the sugar industry are very important. So that's why we have written here high temperature resilience, because the sugarcane juice typically comes around 102, 101 degree centigrade. So we don't want to lose that energy by cooling it. So the whatever system is offered should have high temperature resilience, and of course it should be superior to whatever is being done today, and that it can be quickly adopted and checked out by the sugar industry. So that's it. The next one, please.
This is the other one, sir. Problem statement 8.
Yeah, so I mean, as we all know, sugarcane juice is used to make sugar, but there are various other co-products that are coming into the sugar factory, and they are sugar is of course the main product, but the other material now, for example, the fiber, in Hindi they call it khoi, and you would have seen that when the person by the roadside is extracting the juice, this khoi is falling on the ground. It's a whitish. So that's fibrous material, which is composed of cellulose, hemicellulose, and lignin. And these can all be converted into various hydrocarbons, various useful materials, or can be purified, like lignin can be purified, the cellulose can be purified. The cellulose in the microcrystalline form is the one that is used in all the tablets that are made, for example. So it has a demand in the pharmaceutical industry. And then ethanol, everybody also knows about as a byproduct or co-product of the sugar industry, which is made from the molasses that comes out at the end of the process. And this ethanol itself is can be a very valuable starting point for products like SAF, which is the sustainable aviation fuel. All over the world, the airlines are aiming and targeting to use more and more of sustainable aviation fuel for carbon reduction. And then ethanol can also be used as a starting material for a few other biochemicals, etc. So any processes, any pathways that can utilize these processes or these products, the co-products, as raw materials and make value-added products out of it, which have a ready market, that can then bring about a new revenue stream for the sugar industry and, of course, make it more profitable. The various examples have been listed there. So it's whoever of the researchers, the inventors who are participating in this hackathon, they can talk about any of these streams which they are working upon. And if we find that to be scalable, commercially viable, then this can be taken further and some support provided to take these ideas to their logical conclusion. Thank you.
Hi, thank you so much, Mr. Singhal, for the explanation and for deep diving into the problem statements explanations itself. I truly hope that everybody who has selected so far these particular problem statements has the right understanding now so far. And I see a couple of questions right there coming in. Requesting all other members, if you have any questions, please do tag us on the chat itself to reach out to us on the chat. post it on the chat so that we can actually ask the questions to our esteemed panel, and you can get addressed to any questions or queries that you may have. But thank you so much, Mr. Singhal, for briefing us onto the problem statements. We'll quickly move forward with our panel to the interest of time. So for our next set of problem statements, I would request Mr. Vivek Verma, Chairman and Managing Director, to join us onto the stage. He's already there, and to help us brief problem statement number 5 and 7. I hope you can hear me, Mr. Vivek.
Uh,
Uh,
I can hear.
okay.
Can you hear
Right.
me?
Awesome. We can hear you,
Yeah.
right? Loud and
Yeah.
clear.
Mm. So the converting flue gas waste into the process energy. Yeah. See, overall, so far in the sugarcane value chain, we are taking a very good care of all the sugar, which is part of the sugarcane. But I think that's where the situation changes. Now, what is not sugar is even more important than sugar itself. So the flue gas, when we just are discussing sustainable aviation fuel. So what is sustainable aviation fuel and why it is called sustainable? Because 85% of the sustainable aviation fuel contains carbon, which is not fossil fuel. Less is the carbon. More portion of the carbon, if it is coming from biomass, it will be more sustainable. So sugarcane, flue gas, whether we collect the carbon from the flue gas or we collect it even before we burn it, then it becomes even more valuable. Means that directly biomass and all the waste carbon stream before actually they are burned, that becomes even more valuable because you have the added energy content in this stream. So roundabout, if we say 300 kilograms of total biomass is coming to the sugar factory, the sugar containing biomass is only about 160 kilograms. The rest, about not even 160 kilograms, it may be about 140 kilograms. So 160 kilograms of the biomass, which is actually a candidate to be captured and to be used as a raw material for sustainable aviation fuel, either through ethanol route or directly via gasification route, or by capturing the carbon from the flue gas and using that carbon along with the hydrogen, the green hydrogen from external source, and that becomes a new revenue stream for the sugar industry, and it is a green stream, and it is one more thing which we have to understand, that the biomass of the sugar cane currently is selling at 3 to 4 times discount over the oil. So actually we have a cheap raw material already available as compared to oil. So the starting point is actually cheaper. The real challenge is the conversion from this solid fuels into liquid fuels, and that's where the distributed sugar factory model is actually going to come very handy. And the biomass availability is assured. It is because we will never stop making sugar. So year after year, we have the biomass assured available, and all we have to do is to convert this material into aviation fuel. And one more good thing about it is that we also get the nutrients harvested. Residue of this process is all the concentrated nutrients, which are even more important for recycling. So all the value from the waste is actually very, very important, and we need to all work on this area. So we are moving to another is smarter cooling for maximum sugar recovery. Smarter cooling. So that means that I think the subject here is more lesser use of heat, and we use more controlled crystallization of the sugar making process. The colder is the masket, higher is the sugar in the sugar form, and lesser is the sugar in the liquor. So we need to actually move from high temperature boiling to lower temperature boiling and use less and less steam for crystallization. And actually, this all helps because sugar is much less soluble at lower temperature than at higher temperature. And lot less destruction happens at a lower temperature than at a higher temperature. So overall, sugar making process has to move to a lower temperature. We were uh, classically operating the conventional sugar factories at around 65 degrees centigrade masket temperatures, but consistently in Khansari industry, the sugar was produced at 35 degrees centigrade or below. Now, these two situations actually, uh, if you see from the losses point of view, 35 degrees centigrade is much better temperature. All we have to do is to improve the process, improve the cooling, and move towards lower temperature for better extraction at earlier stages. The sugar and reduce recycling of the sugar in the entire manufacturing process. So this is also very important to reduce the losses by reducing the temperatures in the entire sugar making process.
Thank you so much. Thank you so much, sir, for the information on these two problem statement. It was wonderful again hearing out the insights from you. People who are watching us, if you have any queries, please do reach out to us under the chat and post your questions if you have any. But thank you so much for your insights onto both of the problem statements. So I'll really and quickly thank you and move forward with the other two problem statements that we left behind. And for that, I would just call up on stage and onto the mic Mr. JJ Bhagat, Managing Director. So if you can hear us, Mr. Bhagat, could you confirm if you can hear us? So Mr. Bhagat will help us with problem statement number 4 and 6.
Yeah, I can hear you, but can you hear me?
I can hear you now. Yes.
Okay, fine.
Great. So
All
I'll
right,
pull
you
up
see,
the
let me,
first.
yeah,
Sure. Sorry. Go
yeah,
ahead, sir.
yeah, you carry on.
So before like I'll just pull up the first problem statement for you, which is problem statement number 4. So on the screen, and you're good to go, sir.
Yeah, okay. Thank you very much, Shakti. You see, what I would wish to add an additional piece of information to what Professor Narendra Mohan has mentioned in the in the second problem statement, and that is
Sure, sir.
regarding the kind of separation that we are looking for. You see, we already the filtration is to the extent of removal of particle size up to something like 180 microns already in the industry, successfully done. So what we are looking forward, what we are looking to is to aim a removal of suspended matter up to 70 microns or maybe 80 microns. That is our, I would use the words requirement at the moment. There are systems already available to remove suspended matter up to 180 microns. So this you can add to what Professor Narendra Mohan had said, so that the participants are aware of our requirements, the requirements of the industry in respect of microfiltration. Okay. Hello. Can you hear me?
Sure, sir. We can hear you. Thank you so
Hello.
much for adding that up.
Can you hear me?
We can hear you,
Hello.
sir. Thank you.
Yeah, all right, fine. Now I come to problem statement number 4. I think that is what has been assigned to me. Problem statement
Yes.
number 4. All right, fine. You see, the issue today is that, fortunately or incidentally, the sugar industry happens to be a continuous process industry. And despite it being a continuous process industry, yet it is managed by so many operators. This is very paradoxical. So, basically speaking, there shouldn't be any operator, because if you place sugarcane on the one end, the process is such that it will move on along the various sequencing of process operation to produce final sugar at the end of it. So where does the operator come in between? But like historically, we have been using. I mean, there have been operators in the plant who have been supposedly trying to monitor the process operations. And to monitor the process operation on a 24-hour basis is very difficult, humanly not possible. And therefore, what we generally feel is that they are there for the namesake only. Therefore, if there can be a process automation, a complete process automation of the plant in a manner that the entire predictive maintenance, the monitoring of the various operations, the sensing of the various operations, and the control of various operations, if they can be managed through instruments and through automation, then not only that the process will be more homogeneous, the efficiencies will go up, but even the costs will go down. And that is precisely the requirement of this hackathon, is that how to make the sugar industry more sustainable. Incidentally, the cost of manpower in the industry today is almost, I would say, roughly about 65 to 70% of the total cost of conversion. So this is a huge, element of cost in the manufacture of sugar. And if this can be controlled or managed in a way that it improves the efficiency also of the plant and the operations, then it will be a boon for the industry. So what we are looking forward to is that we must have a robust automation system and control system in place, such that the entire plant can be operated in a manless manner. I mean, there should be hardly any requirement of people or manpower within the plant, right from the cane handling up to the sugar bagging. Apparently it is very easily possible, but a system has to be kind of coordinated in a manner that this happens. And for this purpose, the sensors are available. We are aware of the tasks which each person in the plant is supposed to do. So that task can be taken over by the process control systems. And in that manner, it should be possible for us to conjecture a system which is able to and control all the entire operation of the plant in an automatic manner. If this happens, then it will make a big difference to all the aspects of the industry, in terms of plant efficiencies, in terms of energy savings, in terms of sugar quality, in terms of output, throughputs. In addition to that, if we have a complete automation of the plant, even the maintenance costs due to robust predictive maintenance, kind of procedures, will be curtailed or minimized. At present, the maintenance cost of the plant is roughly about almost like $1 a ton, and that has been there since last many years. And as the value of the dollar has been going up, so also in the terms of equivalent rupees, the cost of maintenance has been going up. So today, the cost of maintenance of a sugar plant is roughly in the region of about 80 rupees to 90 rupees a ton of cane. And I very much hope that if we have the right predictive methods in place, there will be the cost of repair and maintenance will go down dramatically. So, in other words, if we have a proper, and since it is already a continuous process industry, it should be easy for us to have a automation control, complete automation of the plant, such that not only that we are able to improve the plant efficiencies, the throughput, and the kind of energy costs, but also reduce on the other costs like manpower cost and the maintenance costs. And in this manner, if this is successful, and if it is replicated in other industry, I mean all other sugar factories in the country, our sugar definitely is going to be much more competitive in the world market than what it is today. So I think this is regarding the problem statement 4. Hello. हाँ, चलेगा.
You're audible, sir. I have switched to
Yeah.
the next problem statement. You can continue with the
Okay,
problem
fine.
statement
All
number
right.
6.
Now, coming to problem statement number 6, that talks about the online measurement of sugar content in sugarcane. Sugar industry, surprisingly, is one of the only industry, perhaps, where we have no clue of the quality of raw material. It may look surprising, but this is what it is. Normally, what happens that in any other industry, the specification of the raw material, the inputs, and the quality of the raw material is already always monitored and then kind of regulated. In our case, first of all, we are left to handle or kind of a crush the sugar cane that is available in our area of operation. So we have no choices. So whether the sugar cane is good or not so good, or whether its quality is as per it meets our requirements or not, no, we are required to crush the entire cane in that area, except that there is some kind of a what you call as a differentiation in price mechanism for sugar cane which is early variety or the sugar cane which is late variety, and it is assumed that the sugar cane of early variety shall have a higher sugar content, and the one in the late variety shall have a lower sugar content. So to that extent, some price differential is kept in the pricing of the sugarcane. But nevertheless, you see, when we wish to determine the plant efficiencies, it is input upon output. So we don't have any idea about what the exact input is. What exactly happens is that whatever sugar we produce, plus we assume or estimate certain extent of process losses, we add to that, and that is our quality of sugarcane. So the quality of sugarcane is estimated in a reverse manner. That means, in other words, if our losses are much higher than what we are reporting, we'll end up mentioning that the quality of sugarcane is very poor, because it is a backward integration. I mean, the sugar produced plus the losses that we report is equal to the content of sugar in the sugarcane. So if we can have a method, an online method, to determine the sugar content in sugarcane, then that will make a big difference in terms of actually realizing the actual efficiencies of the plant. And then there can be a very little scope for manipulation, if I'm permitted to say that. So I think to the sugar industry, an online measurement of the sugar content in cane is very important. And if this can be made possible through non-invasive methods, then that will make a big difference to the plant efficiencies of the industry, because then in that case the operators will precisely know as to what exactly are their plant efficiencies, and they'll work for it. There are methods. I think there are methods available which can determine the coal in content, sugar in content inline. And one of the methods that we had tried many years ago was near infrared techniques. So in a near infrared technique, you see, it is possible to determine the sugar content in sugarcane in a non-invasive manner. This we had done. This personally I had done it in collaboration with National Physical Laboratories, New Delhi, and it was the entire process on the experimentation was done at Mawana Sugars, and we are fairly successful in doing so. But that was about almost 15 years ago. I think the technologies have developed since then, and with the help of the modern systems and the available technology that we may be having and the know-how that we may be having now, it should be possible for us to identify a method or a system through which we can determine the sugar content in sugarcane inline. And therefore, that is the purpose of this problem statement, that we are looking towards somebody to offer us a methodology through which it is possible to determine the sugar content in sugarcane inline. Yeah. Okay.
Thank you so much, sir. Thank you so much, Mr. Bhagat, for your kind information onto these problem statement. It was wonderful hearing from all our esteemed speakers and mentors and for briefing out all the problem statement that we have collectively here with us today. So couple of questions that I see onto the chat. Moreover, there is one question that primarily has attracted my view, is circling around intellectual property rights and protections of the solutions that people are intending to build around these problem statement. So I'll read it out and I'll flash it right onto the screen real quick. And maybe any one of you or collectively, or if you can answer to that question. So here's the question for you. So Mr. Lalit has asked this question. Intellectual property protection is a critical concern in the era of driven by data and ideas. What measures are in place to safeguard the interest and rights of participants in this? So if any one of you can take up this question.
Uh, may I answer a little on this?
Sure, sir. Please go ahead.
Uh, See, by and large, intellectual protection is covered under the patents, under the various uh, laws which are already existing. Now, the in our uh, platform, whenever whatever information that we are going to share, it's a common subjects, common problem, and there will be multiple methods through which these problems can be solved, and each one of them can be applied with a uh, level of protection that every innovator has. But if we discuss these problem statements properly, then we can solve them by several methods, and every method is protected if one wants to. And there will be many more methods which are actually open and have not been applied, and the IPs on that sector has already elapsed simply because lack of application. So there will be a lot of stuff on the IPs already available, which is already lapsed. So it's a very good discussion. It's very important to discuss in such a open platform, and we need not to worry about IPs too much while discussing on this platform.
Thank you so much, sir, for adding that up. Mr. Single wants to say something. So you're on mute in case you're speaking. You can unmute yourself once.
Can you hear me?
Yes.
Okay. No, it's a pertinent question. Whatever ideas, etc., are received, have to have the assurance from ISMA that will remain the IP of the particular person who is giving the idea. And should that idea be taken up further for any further development work and all, at that point in time, the IP knowledge shared can then be discussed with ISMA as to what will be the role and what will be the distribution of that IP between ISMA and the inventor or the proposer. That will be the honest way of doing it.
Thank you so much, sir, for
No,
putting
I
it
think,
right there.
can you hear me? I think, hello, can you hear me? Hello.
Yes, yes, we can hear you.
You see, I think it is a very genuine apprehension, and we should have a well-defined methodology to ensure that the intellectual property is protected. Because you see, many of the participants would be coming up with some innovative thoughts and ideas, which can be developed by them or by anybody else who tries to capture that and kind of steal the march over them. So we have to be very specific as to how this is to be done to ensure that we give enough confidence to the participants that they will not be shortchanged.
Thank you for adding that up real quick, sir. Thank you for all of your inputs right there. Uh, I have another quick question asked from Shruti. So Shruti has this question around what is the weakest link in today's sugar mill automation infrastructure? So if any one of you can take up this real question real quick and help us answer due to the interest of time.
Yeah, I would like to do that straight away.
Go ahead, sir.
You see, the weakest link itself, the weakest link, as I already mentioned, is the quality of the input material itself. We are not completely aware of what it is, and until unless we are assured of that, or we are confident of we are saying we are very we have the right values of that. It is very difficult to estimate the plant efficiencies, and in absence of estimating the right plant efficiencies, the scope of improvement gets automatically kind of negated. So I mean that is the weakest thing I feel that one of the most important thing is that if we can beforehand know the quality of input material, a lot of things will change in the industry.
Thank you for adding up your pointers there. We'll pick up one last question, and then we should be able to close this session for today itself. And if you still have any questions, you can always reach out to us at SugarNXT Innovate at hack2skill.com. Our support lines are open, and we should be more than happy to help you out with any questions that you may
I
have.
think there was a question in the chat box with respect to the time required in replacement of the knives and hammers. I think if you can see that.
Yes, yes,
Somebody
yes,
has
yes.
raised the question.
That's the first question picked up by Aditya. So here's a question which is approximately what is the average time taken to replace the cutting and crushing
Right,
tools
right. It is generally
mentioned in
4 to 6
problems?
hours. Yeah.
4 to 6 hours. Okay, Aditya, that's for
Yeah.
you. So this is another question that we can pick up. If we design an AI-based near manless sugar mill, what is that one mistake we must absolutely avoid? So do you want to pick it up? Any one of you want to pick it up real quick?
Very difficult to say. I mean, every all the this thing are important in achieving that objective. I mean, whether it's monitoring, whether it's sensing, whether it's control, they're all equally important.
True, very subjective question, maybe. And thanks for putting that across through, and thank you so much for pointing it out real quick. But with that, I thank all our esteemed speaker panel for sparing this much amount of time and helping us answering to the questions and briefing us through the problem statement. It was wonderful speaking to all of you. I hope all the participants here who have joined us had a great time learning more from you and had a great time learning about this hackathon itself as well. But thank you so much. We look forward to hear back from you every now and then coming forward. We sync up. But for the participants, if you still haven't registered, please do check out the webpage. Register yourself. It's a great opportunity. You have a lot to take out from this hackathon, and it's a great journey that we are taking you through. But thank you so much for the day itself. Thank you so much, our esteemed speakers. If any one of you want to say any last things to our watching participants, more than welcome.
Thank you.
Uh, I would like to add that the overall, with the arrival of AI and with so much of multidisciplinary knowledge now available to everyone, we should aim at the globally number one benchmarks for our sugar industry in every area of operation. And it is now knowledge is no longer the limitation for achieving the performance. So we must use these tools in the best possible way and design the factories with the highest performance targets. And it is possible now. We knowledge is no longer limited. The whole world is now using the same platform as the any European or American or Japanese companies.
Okay, Shakti, we done?
Thank you so much, sir. Yeah, we're done. Thank you so much. And thank you so much, everyone watching us today.
Thanks, everybody.
Thank you so much.
Thank you. Have a great evening. Thank you so much, everyone.